These are my Audio-Technica ATH-R70X headphones. I really like these, but they're not really what I want to talk about today. What I want to talk about today is, sorry for the banging around, how I plug them in. Now this is a FiO BTR3K, which is essentially FiO's least expensive Bluetooth adapter. You can also use it with a USB-C cable as a USB headphone DAC amplifier. And to drive these headphones, which take a fair amount of power and they're 470 ohms, I run this in balanced mode. And if you look at the bottom here, if that's focusing, you have headphones and you have balanced. And balanced on this device uses a 2.5 millimeter jack with 4 conductors. Now, most of the time this is what I want to use, but sometimes I want to use these headphones with a computer that can drive them without this, or with a device that can drive them without this. Now I could change these cables, they change easily enough, with the ones that the headphones came with. This is not a great cable, but it's fine. This is a balanced cable for these headphones, which can be had from a number of sources. But I like this relatively short cable length for most things that I use. So I ordered this, and this is a 2.5 balanced adapter to unbalanced 3.5, so normal 8-inch headphone jack. Now what I want to talk about today is really this adapter, and why this adapter, which goes from an unbalanced source to balanced headphones, is okay, but you can't do it the other way around. So you can't go from a balanced output to, so if this was balanced, you can't go from balanced output to an unbalanced set of headphones. And that has to do with the way balanced headphone amps are wired. So what I'm going to do is I'm going to put away this stuff, bring up the screen on the computer. We're going to look at Wikipedia, we're going to look at the web page for this thing, and that will be sufficient, I think, to understand what's going on with this stuff. So what I'm going to do for you next is I'm going to talk a little bit about this little FiO device that I'm using. We're just looking at FiO's web page here. And they've got a diagram which explains how it works. So we can see the advertising stuff. But here's a little diagram, sort of a block diagram, that explains how this is designed and how the balanced output works. Okay, so we have the USB going in, and we have this chip, which is a Cirrus Logic, whatever that they've got in it, that takes in the USB signal. And there's the USB driver module. It's got the antenna, it's got a clock, and this is going to be providing the Bluetooth receiver. And it's going to handle switching between data rates. It's probably programmable to handle the relatively minimal display it has. So this is essentially working as the microcontroller that drives the whole thing. But what is it really? It's a Bluetooth chip. It then sends out a digital signal to these two chips here. And these two chips here are DACs with built-in headphone amplifiers. And they have two different clocks to handle, I think it's 44.1 and 48K, which is the sample rates are, the sample rates that that this device supports. I'm assuming that's correct. That's really outside my knowledge. Okay, so let's look at how they're wired. Each one is wired to handle a single channel. This one handles right, and it has right, plus, and minus, and this handles left, and it has left, minus, and plus. If you're looking at the 3.5 millimeter jack, right, that's not the balanced ones. We have a typo in that. But if we're not looking at the regular 3.5 millimeter jack, it comes in from the plus, and it comes in from the plus side of this chip as well. So we've got the left and right come in, and the ground is going to be a separate ground, which is not drawn here. So that will go to the ground, which is going to be the same ground that's used by both of these chips. But it's only connected to the positive output side of these two chips. The 2.5 millimeter jack is connected to the positive and the negative, and is connected to the positive and the negative for the left. So each of these two sections, right, the left and the right, are connected independently. They don't share the ground that has to be shared by this one. So let's have a look, come back to the camera and have a look at what this means in practice when we see it on paper. So here we are looking at the same diagram. I'm sorry, this is my Credi printer. It will be replaced probably tomorrow, but at the moment that's what I've got. And I'll zoom in a little bit so that you can see what we're looking at here. So this is the same diagram we were looking at before. What I'm looking at in the background here, just off screen, is how jacks are set up. And I'll just write this over here, but typically a connector is tip, ring, sleeve. So typically the way this is set up, so this is an audio jack. We'll use this one here. There's an audio jack. Tip, ring, sleeve, so that's the tip, that's the ring, this is the sleeve. And typically the way these are wired is this is left, this is right, and typically the sleeve is the ground. Right, so left, right, and ground. Now, there are lots of things with 4 conductor cables. So this is the 4 conductor one for my headphones. Now, if this was a regular 1.8 millimeter, just so you can see the relative sizes, there's a big difference in size there. Now, if this was like one for an iPhone, would go tip, ring, ring, sleeve. And if you look at the way these are set up, the tip is left, the ring, first ring is right, the second ring is ground, and the sleeve is mic. So this is the way a standard iPhone cable is wired, and that's how you can end up with a mic on your cable. And so if you were to see a 3.5 millimeter jack with 4 conductors, this would be what you would expect. But what happens if you've got a 2.5 millimeter jack that's designed for balanced use? Well, there you also have tip, ring, ring, sleeve. But how are they done? Balanced connectors are usually going to be 2.5 millimeter or 4.4 millimeter. This is probably the more common balanced standard. So let's bring this back in. Sorry if I've been out of. Okay, so we've talked about this is the way a standard 3.5 millimeter jack is set up. And there you have tip, ring, sleeve, left, right, ground. On an iPhone, you have this, but with a second ring, right? So you get tip, ring, ring, sleeve. So you imagine there's a separate ring here. And there it goes left, right, ground, and then in the extra ring here, there'll be a mic connection. And so that's how you get the microphone input into the same style plug here. Do I have one floating around? Only on the microphone I'm currently using. I don't have anything within reach. However, if you want a balanced connection, you can't really use a 3.5 millimeter jack, because every 3.5 millimeter jack you're going to use is going to assume that there's a microphone there, and if you plug it into an amplifier, you're likely to destroy it. So balanced outputs tend to use this, which is a 2.5 millimeter, which I'll show you is much smaller than the 3.5, or a 4.4 millimeter. The other standard you would use for this would be 1/4 inch, right? Which would be, again, I don't have one within easy reach right now, but that would be your standard large size, old-fashioned phone. So how do you wire the TRRS? This is wired is completely different. So the tip is right minus, and we've got right plus. The second ring is left minus, and then the sleeve is left plus. And so you can see that this doesn't have any relationship to this, right? So we want to hook these two together. That's what this plug does. So now that we know what the plugs do, what's the problem with hooking, with doing it one way and not the other? So why would this, so the question is, why is this fine if you're going from TRS unbalanced amp to TRRS balanced headphones, right? That's okay. But if you wanted to go the other way around, that's no good. So if you wanted to go from a balanced amp to unbalanced headphones, no go. So the first thing, of course, before we go back to this diagram, is to note that headphones are all inherently balanced. There's, a speaker here, right, with a magnet in it. It's got two wires coming out. We can call them plus and minus. And there's this one. There's another speaker, magnet in it, plus and minus. And there's a headband connecting them. That's all there really is to headphones. If they're IEMs, you don't even have the connecting piece, right? Okay, so this means that there's no problem. You can wire these up to this TRS balanced connector, no problem, right? We've got right, we've got left, right? We've got tip, ring, ring, sleeve. Right? There's our plug, tip, ring, ring, sleeve. No problem, just like this diagram here. And so we've got no problem wiring those up like that. But usually what happens is we bring out, we'll say the negatives here, we bring them out together, and we wire those to the sleeve, and then we bring this down here. That's right, so we wire that to the ring, and we bring this one down here and wire that to the tip. Right, and then you get this. I should make it bigger, but right, so tip, ring, sleeve. Got the whole thing in the, sorry, I didn't have the whole thing in the screen before. So you'll notice what we've done is we've put the two negatives together. We've put the two grounds together. Now, if we go back to this diagram, we can see that on the 3.5 millimeter output, it's expecting tip, ring, sleeve. So it's expecting a single ground, it's expecting the right, and it's expecting the left. Right? And you'll notice that we see the right positive and the left positive here, and we would also have, which we're not seeing here, ground. Right? That's what it's electrically expecting. It's not using the negative half of the output of these two modules. On the balanced side, it's expecting tip, ring, ring, sleeve, and it's expecting left plus, left minus, right plus, right minus, right? So these are electrically isolated, right, from each other. So what happens if you plug this isolated output into this? Well, they're not isolated anymore. You've now shorted this and this. And they're not designed to be doing that, and you might blow something up or set off the safety circuit in your device. On the other hand, you can do it the other way around, right? If you're coming out of this output, all you're doing is going from here to, well, we're going from, so if we go from tip, ring, sleeve, so this is over here, so we're starting with the 3.5 inch unbalanced, right? We go from tip, ring, sleeve, so this is going to be left, right, and ground. So we're going to go to 2.5 balanced, tip, ring, ring, sleeve. So what are these supposed to be? Remember, sorry, I got it backwards here. It's going to be right plus, right minus, left plus, left minus. So what we're going to do is we're going to take the grounds and we're going to tie those like that. And then we're going to put left and right. These are, I wrote these out backwards, but it doesn't really matter. Okay, so you'll notice that we've just tied the negatives together. But that's okay because they're tied together here, right? And they're tied together here at the amplifier. We don't do any harm by doing that. Do it the other way around though. So if we go from TRRS, right, and we go right positive, right negative, sorry, left positive, left negative, we go to TRS, and we go and we tie those together, and we just tied the two channels together that aren't expecting to be tied together. We've created a problem. Hopefully that makes sense, right? And it comes down to the fact that, well, headphones are inherently balanced devices because each ear is independent. There's no problem tying the grounds together for the headphones because they don't care, right? They're just speakers. There's dynamic headphones, there's just an electromagnet. That's it. That's all there is in there. It's not, in principle, very complex. Making it work well is complex, but the device itself is not inherently very complex. So if your amplifier is happy to have the grounds tied together, then that's fine. However, if your amplifier is not, then that's also fine because you can just wire them each independently. You just need to use a different kind of cable. But you can't go the other way around. So if your headphone cable is only wired with 3 wires, then that's what you've got unless you change the cable. Hopefully that makes some sense. And I think that's all I'm going to say about this for now. But it just shows how it's convenient to have these devices, but it's also nice sometimes to be able to go from your balance cable. And it's nice sometimes to be able to go from your balance cable to an unbalanced cable like this quite conveniently. And there are cables that are made with a series of adapters that allow you to take a balanced cable to a variety of different unbalanced connectors and to also different styles of balanced connectors. And that's a big convenience if you happen to have equipment that supports that sort of stuff. These things are real fingerprint magnets. Anyhow, hopefully that was helpful. Hopefully that makes some sort of sense. Thanks for watching.